Okay, so for number one, we have a 20 centimeter tall object 40 centimeters in front of a thin lens, which has a focal length of plus 15 centimeters. So back over here at the board, and I've got my little chart already drawn. Here, this first blue line here is going to be our ground line. And then the green here is a lens. So lens, the object's 20 centimeters. The object distance is going to be 40 centimeters. Before we move any further, other information that I think is important for us to put on here that is just good to know is that when you are on the object side of the lens in these cases, I'm not going to say that it's an all cases thing just in case we get some where they're flipping them around for some reason, but this side of the lens where the object is, where light's going to be going through, into and through the lens, this is technically a negative side. The left side is negative, okay? And then here we go through off to the right. Come on, thank you very much, camera. Over here off to the right, once you've passed through the lens, light's passed through the lens and is coming to either at a focal point or wherever it's going through, it's going to be a positive distance. So in the number one, we're given the 20 centimeter tall object, 40 centimeters away from the thin lens, and the distance is a positive distance, so it's the focal length is a positive focal length, so it's on the right side of the lens, and the dot here, that's going to be F. This is going to be F, and F equals, in this case, 15 centimeters. I'm leaving the positive there because it lets us know. So yes, again, 20 centimeter tall object, the object distance is 40 centimeters in front of the lens, which means that when we use U later, U is going to be negative because left side of the lens is a negative number. Going through a lens, positive 15 centimeter focal length, which means that if the image is on the right here is a positive image, this image is going to be real. It is supposed to be an R. It's an R. Shh, don't tell on me. Real. And then when we draw it, when I get the lines on there, we'll also know that it's going to be inverted. Sorry about the glare. Inverted. And that this lens, because it's on this side, is also a plus lens. It's a plus lens. And that's going to be knowing the cases that we have. So pausing the video again. This is number one again. I know that I paused it, but I stopped for a second. I had to remind myself I had to walk away. So the question asks us whether or not, what is the image distance? So that's going to be V. What is V? What is the magnification? And what is the image size? So we're going to go through for each one. The other questions are, is it a plus lens, plus or minus lens? It's a plus lens. Again, it's because the focal length is over here on the right side. Because the focal length is over here and the image is going to be over here for this one. Besides the one case that we have that's really odd for the plus lens, this is a plus lens. And that the image is going to be real. And that it is also inverted. In this case, we know this in this case, and math will tell us here. So V, to find V, we've got minus 1 over U, which in this case, U is going to be minus 40 because it's on the left side, plus 1 over V, which we don't know, equals 1 over the focal length, which here we know is positive 15. This is something that I told you guys on the thing. I'm not the best at, but minus 1 over minus 40. Two negatives make this into a positive, so this is 1 over 40 plus 1 over V equals 1 over 15. You subtract 1/40 from both sides. 1/40th from both sides. So now we've got 1 over v. Pretend we don't see all that. We've got 1 over v equals 1/15 minus 1/40th. 45, 60, 75, 90. Why am I suddenly not able to? 105. I could just do this in the calculator. Hold on. Okay, so putting this in the calculator, you get 1/15 minus 1/40th equals somewhere around, I usually round to 4 places afterwards, so it's going to be 0.0417. So 1 over the image distance equals 0.0417. Technically, what you'll do is you can technically cross multiply, and you're going to be like, don't do that to me. No, it looks like this. So for a number to be a whole number, it's whatever that number is divided by 1. Why? Because 1 into anything is whatever that number is. So cross multiplying is going to be 0.0417 v equals 1, where v equals 1 divided 0.0417, where image distance is about equal to 1 over 24. I believe that's what he's got. So 24 centimeters, that's what we're working in. So, all right, so we know that the focal length is 15, which means that the image is going to be somewhere along over here at 24. So this is going to be V, or 2F. This is where 2F comes in. 2F is 2 times 15, which equals 30. So the image falls somewhere between F and 2F at 24 centimeters. Don't know, I can just get rid of that there now since I'm doing that. Keeping each thing on certain sides of the line. Soup. So putting over here, we were putting it on the sheet, would be where we needed to. So image distance, which is V, is somewhere around 24 centimeters. Magnification is next, so M equals V over U. I keep forgetting about that glare, equals I over O. We're about to use I over O, so I'm going to use them both up here. V, we know that V is somewhere around 24. We were given U. U is 40. It's technically minus 40, but 24 divided by 40 is about 0.6. It's a 0.6. So it's a negative 0.6. I'll tell you why I'm using the negative here in a second. I think that I did on the thing as well. So we now know that magnification, and the correct way I think to write this for him is to put it as a full number, is to do 0.6. But the reason I'm doing the negative will be made apparent here in just a second. And that is magnification, 0.6. So image size, you can do 0.6 equals image I, which is image size, which we don't know, over the object size, which is 20 centimeters. And again, you throw a 1 under there, you can cross multiply. So it becomes magnification of minus 0.6 times 20 centimeters is equal to I. So going on down here, 20 by minus 0.6 equals I is equal to minus 12 centimeters. Okay, so when you're writing your answer for Mike, don't use the negative. The actual image size is 12 centimeters. What does the negative mean then? The negative in this case means that it's inverted. It tells you that your picture is below the blue line. So our picture is going to come out over here. I'm going to pause the video and I'm going to get us started on the drawing. All right, I got a new color. I've got my red marker, which I'm so glad that my sister-in-law had the big whiteboard left here since I'm home now. So light comes in across this. Here's the first ray we draw. Hits here, so this ray should go, I believe that it goes through. Yeah, it goes through the focal length and down. We're just going to keep drawing it where it keeps going down. The second one goes through the optical center. There it goes. And then the next one goes down. I believe that this one's still part of the same case. It goes through and runs parallel. I didn't draw that very well. But the image is where they'll all meet. It's going to be upside down. I think some of the cases, or one of the plus cases, does not have this line. I don't think it's this one. I think personally that you can probably just use the other two and figure it out. But yes, so we have a real inverted image up here. And this was fun sheet 1. I forgot to write down the number. This is number 1. Yeah. I hope that helps some. So, yes.